Alright, now we shall come to the next part, which is called thin lenses. Okay, for thin lens, the light can pass through. Yeah, just like you can see here, the incident ray. Yeah, let me draw. So you can see the light incident ray coming in, and then refracted ray. It is passing through the mirror. Okay, it's not reflected out. This one is also under, we call under the refraction. Yeah, refraction. This one is also under refraction. The light can pass through. Okay, for thin lens. Okay, it's not like the mirror. The mirror, the light cannot pass through. It's reflected away. Yeah, reflected away. So first of all, what's actually the difference between mirror and lens? Okay, you see mirror and the lens. What's the difference between these two? Okay, first difference is mirror. It only has one surface, one curved surface, but and then it only has one radius, because it only has one curved surface. That's why it only has one radius and one focal length. The focal length and center curvature is only at one side. But for thin lens, it has two curved surface, so it has two radius and two focal point. So let me show you. Yeah, let me draw again. This is the mirror. Mirror. Okay. Mirror, it only has one curved surface. So it only has the center curvature and the focal point is only one-sided. You see that? Only one-sided. But for lens, let's say I have this lens. Okay, I have this lens. So it has two curved surface. So it has two sphere, we can say. Yeah, it has two sphere. Yeah. This is one sphere. Here is a one sphere, and then here has another sphere. You see that? So it has what I can say, it has two center curvature, and of course it has it has two focal point. Understand? This is what we call lens, thin lens. Thin lens. Okay, thin lens, it has two surface, and that's why it has two radius. So like just now, for mirror, it only has one radius and one focal length. Okay, but this one, thin lens, it has two surface. So this is surface 1, this is surface 2. So here is one radius, radius 1, and then here is another radius 2. Yes, two radius. So for mirror, very easy to find the focal length. We just use focal length is just radius divided by 2 for mirror. But for thin lens, because we have two radius, two different maybe same radius or different radius, so we cannot just radius divided by 2 to find the focal length. We need to use the lens maker equation. We need to use lens maker equation to find the focal length of the thin lens, which is this formula. You look carefully, 1 over f equal to n2 over n1 minus 1, 1 over r1 minus 1 over r2. See that? Because it has two radius. This one only has one radius. Okay, then you can find the focal length. But this one has two radius, radius 1 and radius 2. If you want to find the focal length. See that? For thin lens, it has two radius. That's why you need to use another special formula. We call it lens maker equation to find the focal length of this thin lens. For mirror, very simple. Just only one radius, so just divide by 2 to get the focal length. And since that thin lens, it has a focal point and center curvature at both sides, we cannot use the incident ray and refracted ray to get the positive and negative sign. For mirror, it's very easy because the radius and focal length is only one-sided. So you can compare. For this mirror, for mirror, to get the positive and negative sign, you can compare the what we say, the focal length with the reflected ray to get the positive or negative sign. But for thin lens, the focal length you cannot compare with the refracted ray. Focal length you cannot compare with refracted ray because it has a focal length at both sides. You see that? It has a focal length at both sides. Here also got, at the right hand side got focal length, got left hand side also got focal length. So you cannot use focal length to compare with refracted ray for thin lens. So that one, focal length, we can only just use the formula, the Lensmaker equation. Lensmaker equation to determine whether f is positive or negative. We can use this formula. We substitute the refractive index, we substitute the radius R1 and R2, the radius for both surface, and then by using this equation only, then we can know whether f is positive or negative. So f is positive or negative for thin lens. For thin lens, f is positive or negative only depend on this equation. You cannot use the comparison incident ray and refracted ray to determine. Okay, you cannot use the what incident ray and refracted ray to determine because it has focal length at both sides. You can only use this equation to get whether f is positive or negative. The sign for f. So if f is positive, we can make a conclusion that if f is positive, then this is a converging lens. Okay, if f is negative, then it is diverging lens. That's all we can make. That's all we can make. Yeah, if f is positive, converging. If f is negative, then it's diverging. Okay. Yeah, and then here you see, okay, so you can see mirror only has one surface, but thin lens has two surface, has two sphere. Mirror only has one sphere. Okay. Now about the names of these, we have here we have a biconvex lens. This is a biconcave lens. This is a concave meniscus, and this is a this is convex meniscus, and this is concave meniscus. So how do you name them actually? Yeah, how do you name them? Okay, if you look carefully, I draw here again. Here we have we call this, what do we call this? We call this biconvex lens. This is biconvex. Why we say biconvex? Because we look at both sides. From this side, we can see this is convex surface because it curves outward. And then from another side, it is also called convex surface. So that's why it's called biconvex. And then we have another one. We have this one. Okay, the next one. This one is called, what is it called? It's called biconcave. It's called biconcave. Why we say it is biconcave? Because from this side we can see it is concave. From another side we can see it is also concave. We look at both sides. Okay, it curves inwards. That's why both of these is both is a concave surface. Now I have another one. What's the difference between these two? This is a convex meniscus, and this one is a concave meniscus. What's the difference between these two? If you look carefully, this one, okay, I should draw here. Okay, I draw over here. I have this. Okay. it should draw again like that. Yeah, I draw like that. Like that better. Okay, like yeah, like that. Like that is better. Okay, and then I have another one is called this concave meniscus. Like that. Okay, what's the difference between these two? If you look at this one, from here we can see. From here we can see this is a. It has one convex. It has one convex surface, and it has one concave surface. So this one has one convex surface and one concave surface. This one also the same. This one from here I can see I have one convex surface. Here also I have one concave surface. Okay, so not like before that. This is both side is convex. This one both side is concave. This one is one convex, one concave. This one also the same. What is the name for this? Yeah, this is called, the first one is called convex meniscus. This one is called concave meniscus. Concave meniscus. Yeah, how to spell the meniscus? How to spell the meniscus? Meniscus. Yeah, meniscus. Now, how to determine them? Yeah, how to determine what's the difference between these two? If you can see, convex meniscus, the convex surface is a smaller sphere. If you look carefully, yeah, I can say like that. I can say like that. This one is a smaller sphere. The first surface is a smaller sphere. So which is this is the R1. Okay, and then for the concave surface, it is actually a bigger sphere. It is actually a bigger sphere. Like that. See that? Because it is less curved. You see that? Because it is less curved. Yeah. The first surface is more curved, so it has a smaller sphere. But the second surface, this is the second surface, it is less curved, so it has a bigger radius. It is a bigger radius, R2. So if the questions give you that lens, it has a convex surface with radius, maybe this radius R1 is 10 cm. Okay, but with a concave surface, with radius maybe 20 cm. This radius 2. This radius 2 is 20 cm. Then it is a convex meniscus. Okay, then it is a convex meniscus. Convex surface with radius 10 cm and concave surface with radius 20 cm. Then it is a convex meniscus. But if you say that a lens, it has a convex surface with radius, this one is the other way around. If you look carefully, this convex surface have a bigger sphere, but this concave surface is more curved. It has a smaller sphere. Look carefully. You see, the first surface. This is the first surface. See that? This is the sphere for the first surface, a bigger sphere, because it's less curved. You understand that? Because it is less curved. Yeah. Draw carefully, nicely. This is the R1. See that R1? R1 is so long because it is less curved, bigger sphere. But for concave surface, this one is a smaller sphere. It's a smaller sphere. Okay, it's a smaller sphere, so it has a smaller radius. It has a smaller radius, R2. We put it as R2. This is surface 2. R2. So for this one, for convex surface, the radius should be opposite. Should be 20 cm. This one, concave surface, should be radius 10 cm. See that the difference? This one convex, shorter, concave longer. This one convex longer, concave shorter. See that? This one for convex meniscus, the concave surface longer radius, but for concave meniscus, the convex surface have a longer radius. That's the difference. Just opposite. So another thing, if you can see, what I can say is these two, I divide them. Okay, I divide them to two. Okay, so for this one, biconvex and convex meniscus, both of these are converging. Both of these are converging length. Converging lengths. And then for biconcave and concave meniscus, both of these are diverging length. And then if you use this formula, length maker equation, if you use this equation, length maker equation, that means if you substitute, let's say just now talking about the convex meniscus, I give the radius R1 and R2, right? And then I substitute into this equation. Okay, R1 I put R1 just now is 10 cm. R1 is 10 cm, and then R2 I put 20 cm. Okay, R2 I put 20 cm. Then I also put the refractive index. I will talk about this later on. Refractive index. Then I can calculate the focal length of this convex meniscus. I can get the focal length. So if I use this equation, I will end up either F is positive or F is negative. Either converging or diverging. And what I can say is, after I use this formula to calculate the focal length for each of these lenses, biconvex, biconcave, convex meniscus, concave meniscus, I use the this is what we call lens maker equation. This is what we call lens maker equation. After I use the lens maker equation to calculate the focal length for each of these lenses, okay, this side I surely, biconvex and convex meniscus, I can guarantee you, I will get F is positive value. If I use this lens maker equation, I will get F is this F I will get positive value. I will get positive value, and it is when F is positive, it is called converging lens. Yeah, for this one, for this these two, this side, the left hand side, biconvex and convex meniscus, I surely get F is positive value. If you don't trust me, you can try later on. I get F positive. But for this side, biconcave and concave meniscus, I surely get F is negative. If F negative means these two are diverging lengths. I surely get diverging lengths. Okay, there's one way to know whether converging or diverging. Actually, why I know this is converging and why this is diverging. Okay, one way is to just look at the name. This is biconvex, convex meniscus, so I know it's converging. This one is biconcave, concave meniscus. Then this is diverging. That's one way, and I use the lens maker equation to calculate. I surely get these two is F positive, and for these two are F negative. Okay, that's two way. Now, another way to detect whether F positive or negative is just compare the center of the lens and the side. You look at here. This one at the middle of it, is thicker compared to the side. The side means over here. At these two sides. You see that? This one, if you look at here, if you look at this biconvex and convex meniscus, the center is thicker compared to the side. So this one is okay. So for this converging lens, it is usually thicker at center. It thicker at center. Understand or not? Thicker at center. That's why it is a converging lens. If a lens it is thicker at center, it is converging. You surely get F positive. You surely get F positive if you apply the lens maker equation. But for the diverging lens, if you look at carefully, the side is thicker. The side is thicker. You see that? The side here is thicker compared to the center. The center is thinner. So for what I can say is diverging lens, it is always thicker at side. Thicker at the sides. It is thicker at the side. This one thicker at the center. Thicker at center is called converging lens. Thicker at the side is called diverging. Thicker at the side, thicker at the side is called diverging. F is if thicker at the center, F is positive. If thicker at the side, F is negative. Okay, that's one very fast way to determine converging or diverging. What I can say is converging lens normally is fat lah. Is fat. For diverging lens is thin. That's it. Thin. Okay. That's about it. About the shape of it. Okay. Now I have finished discuss. Okay. Now you know the convex if 10 cm, concave 20 cm, convex 20 cm, concave 10 cm. They end up with different characteristics. One is converging, one is diverging. Convex meniscus and concave meniscus. Okay. Now let us continue with the equations. Now for this one, for lenses, we have these three equations. You see, for this thin lens, we also use the same equation, 1 over u plus 1 over v. Okay, 1 over u plus 1 over v equal to 1 over f. We call this thin lens equation. You see, it is actually similar to the mirror equation. Mirror equation also use the same formula, 1 over u plus 1 over v equal to 1 over f. This one is known as mirror equation. They use the same formula. They use the same formula. Yeah, thin lens and mirror. They use the same formula. This one is called mirror equation, and this one is called the thin lens equation. They use the same formula. Only different is to find the focal length. For mirror to find the focal length is very simple. Just f equal to radius divided by 2. Because radius is 2 focal length. So to find the focal length for mirror is just take radius divided by 2. Because it only has one radius. What I say is, I mentioned before, for mirror it only has one radius. That's why it's very simple. But for thin lens, it has two surface, it has two radius, R1 and R2. You need to use the lens maker equation to find the focal length, R1 and R2, which involve R1 and R2. Okay? So say for mirror, just to find focal length is radius divided by 2. But for the thin lens, to find the focal length, you need to use the lens maker equation, which is n material divided by n medium minus 1 over R1 minus 1 over R2. Be careful, this is not R2 minus R1. This is not R2 minus R1. Is R1 minus R2. Careful, this is R1 minus R2. 1 minus 2. The first surface radius minus the second surface radius. Okay, I will show one by one. Now, What is n material? What is n medium? N material means the refractive index for the lens. So I can say, what I can say is this one. Look carefully. N material means the lens. N material is actually the lens. The refractive index of the lens. Refractive index of the lens. N medium means is where is this lens placed? It's a medium outside, outside the lens. This is the refractive index for outside is N medium. Understand? So for N material or lens, this is normally using glass. This is normally using glass or maybe some other material. There is the refractive index for lens, normally glass. But for medium outside, normally is either air or water or oil or lead or any, maybe glass also, yeah, oil. So it can be depend on the questions, yeah. What kind of medium is this glass placed onto it? Okay, this medium, this is the refractive index of the outside medium. Okay, now -1, and then you see this, if N medium is air, okay, if this, if outside is air, all right, sorry, if this is the medium is air, hold on a second, yeah, 一下子点，一下子。Okay, now if this medium, okay, if medium is air, if the refractive index for medium is air, then this refractive index is value equal to 1. Value equal to 1. Now, so it can be simplified. The formula can be further simplified. If the medium is air, this n equal to 1. So you also can simplify the formula into this 1 over f equal to n lens, okay, because the material is the lens lah, refractive index of lens, -1, and 1 over r1 minus 1 over r2. Understand? Because the medium is air already, so n equal to 1. And then, yeah, if a flat surface, plane, plane surface. If plane surface, the radius is infinity. That means sometimes I have another type of mirror. We call it plano-convex. Let's say it can be a plano. Again, it can be a plano-convex or plano-concave. Yeah. This is a plano-convex. This is called plano-concave. Okay. For this plane, we actually learned before. For plane surface, it has infinity radius. Last time I talked about the plane mirror. It has the infinity radius. Yeah. So okay. That's why last time talk about the mirror equation. Last time when we talk about the mirror equation, we know that radius equal to 2 focal length, isn't it? So when this is infinity, the focal length also infinity. The focal length also infinity. So when we use the the equation for the mirror equation, 1 over u plus 1 over v equal to 1 over f, and this one is you know, this is equal to 1 over infinity, because plane mirror is radius infinity, focal length is infinity. So that's why you have what we call this this one 1 over infinity. When 1 over focal length is 1 over infinity, you get 0. You get 0. Yeah, you get 0. So 1 over u plus 1 over v equal to 0. So 1 over v equal to negative 1 over u That's why you get V equal to negative U. You see that? That means for mirror, if I have object, if I have an object over here, this is the U. Okay, this is the U. Actually, if you use the plane mirror every morning to look at your beautiful face, isn't it? Your handsome face, your beautiful face. So if you look at the mirror, you can see the image is formed the same distance as the object. You see and it is upright, isn't it? You see the image in your mirror is upright. It's not inverted. Upright means it's a virtual image. So you see it is an upright image. Upright image is a virtual upright, same size. Yeah. Because V equal to negative U, you see that V equal to negative U. So that means when U is positive, when U is positive, object is a real object. That's why V you get negative. That's why you get a virtual image. That's why it's called when V is negative. When V is this V is negative. This V is negative. This is a virtual image. The image you see in the mirror is actually a virtual image. You just see the image inside the mirror. You understand that? You just see the image inside the mirror. The image in the mirror cannot be formed on screen. Yeah, it's just a virtual image. And then they have the same distance away. Yeah, same distance away. If that means object distance, let's say, is 10 cm, then the image distance should be negative 10 cm also. Same distance away. Yeah, same distance away. That's because V equal to negative U. Virtual upright. If I say the mirror, last time you remember incident ray, about the incident ray and refracted ray. Refracted ray. So this V and the radius is opposite side. You see that the refracted ray and the reflected ray and the image distance is at the opposite side. That's why this V is negative. Okay, and that's why I use my method. Can use for the whole chapter. Okay. That's about mirror. So I just want to mention that the plane mirror, the radius is in, because it is just like a very big sphere. So like for this one, where is it already? Okay. For 1 second. Yeah. For plano convex and plano concave, so let's say also it has a very big sphere. Yeah. Also it has a very big sphere. So this the first surface, it is like radius equal to infinity. The other one is like equal to infinity. For the second one is like also a very big sphere. The first surface is radius infinity. Okay. For the second surface, if it's a smaller sphere, second surface is R2 lah. Smaller sphere. This one also the sphere is over here, so this is the radius 2. Okay. I just want to say that for plano convex, this is a plane and a convex surface. Okay, that means from this side I see is a plane. From this side I see is a convex. From this side I see is a plane. From this side I see is a concave. Concave. That's why for this one is called plano convex. This one is called plano concave. You can see here, this one is thicker at the center, this one thicker at the side. This one is also converging, this one is diverging. Okay, this one you get F positive, this one F negative. You don't believe me, you try and calculate and see. Yeah. Okay, so hold on a second. Yeah. Yeah, so this just divide these two. Okay. Yeah, so this is converging and this one is diverging. Okay, so remember plane surface, radius is in. Now let's look back to our a lot of things I've explained. Now we still stick in the lensmaker equation. Okay, lensmaker equation. Now, I already talked about the refractive index for material and refractive index for medium. Now, what is this R1 and R2? How to determine which one is R1, which one is R2? Very simple. Okay, if you look carefully, like this one, if you look carefully from here, you need to know where is the object first. You need to know where is the object. Object, like this lens is over here. So this object is at here. So the first surface it encounter is the first surface. And then the second surface for the refracted ray, it is the second surface, or R2. I can say like that. If the object at the other side, then the other side is the first surface, and then this surface become the second surface. Okay, I can show you over here. We can show you over here. This is the convex lens. So if my object is over here, it depends on the object. Where is the object? You understand? You can place the object at the left hand side or right hand side. You can place anywhere. So if you first, my method is you must first draw the incident ray and refracted ray. First you must draw the incident ray and then the refracted ray. Understand? And then the surface that receives the incident ray is surface 1. This is the surface 1. So this is the radius 1. Understand or not? This is the radius 1. Okay? And then the surface that the light goes out. The light goes out, it becomes the refracted ray. That one is the second surface. That one is the second surface. Over here. This is the second surface. And my R2 is over here. My R2 is over here. This is my R2. Understand or not? The first surface is the incident ray, and the first surface receives the incident ray, R1, and then the second surface where the refracted ray goes out. That is the second surface. That is the R2. R1 is going to the right hand side because the shape of the sphere is at the right hand side. See that? The sphere is at the right hand side. But for the second surface, the sphere is at the left hand side. The sphere is at the left hand side. So that's why the R2 is to the left. R2 is to the left. I already tell you about R1 and R2. I might as well talk about positive and negative sign. For radius, I also compare with refracted ray. Understand or not? For radius of each surface, I also compare with refracted ray. That means like this radius, if the radius same side with refracted ray, then it's positive. If opposite side is negative, like this radius, you see that? This radius is same side as the refracted ray. I compare, because the light can pass through. This is the we call refraction. Refraction, the light can pass through. For refraction, the light can pass through. This is just a piece of glass. So the first surface radius, this radius is same side as refracted ray. So we can say this is R positive. This one is R positive because same side as the refracted ray. Okay, same side as refracted ray. But for this R2, it is a negative because it is opposite to the refracted ray. You see that? This one refracted ray at the right hand side, but this radius 2 is at the left hand side. So at the opposite side. So this is the negative radius. That's it. That's it to determine whether it's a positive or negative sign for the radius. Very easy. So we can know this R1 is positive or negative. By just drawing the diagram. No need to memorize convex surface or concave surface. Understand or not? Okay. So just now I talked about the first surface and second surface. If object at the left hand side, then the left hand side surface, the first surface that encounter the object is the first surface, and then the another surface which later than the first one is called the second surface. If the object at the right hand side, let me show you. What if the object at the right hand side? I can place the object anywhere. So if the object is over here, then I first must draw the incident ray and refracted ray. Incident ray must come from the right side. This is the incident ray come from the object, and refracted ray pass through the lens at the refracted ray at the other side. Now, which surface is the first surface? The first surface that where the incident light enters. This is the first surface, not this one. Okay. So which one is first surface depend on where is the object. This one, this one this one is the first surface because the incident ray. This one is the second surface because of the refracted ray. This one is the first surface because it's the incident ray. And then where is the radius? Where is the radius? Let me show you. This is the first surface. Okay. The radius. This is then this first surface. This is the R1. This is R1, and then the other surface where the refracted ray come out. That is the second surface. I use the other. I should use this and this is the second surface. This is R2. Understand or not? R2. For this case, this one R1 should be positive because same side as the refracted ray, and this R2 should be negative because opposite to the refracted ray. This one is negative. You see the one method used for the whole chapter, for all subtopic. So this radius is opposite to the refracted ray, so it's negative. Understand? So just now this is the second surface. This is the second surface where the refracted ray goes out. So this is the second surface. This is the second radius. So that's how I identify the R1 and R2 for lens maker equations. Understand or not? And then it must be R1 minus R2, not R2 minus R1. Okay, now and then of course magnification also we use back the same formula. Hi over ho, the height of image divided by height of object, equal to negative v over u. Okay, negative v over u. So it's the same as the mirror. Mirror also use the same magnification formula. Mirror, see that? Okay. Now look at I want to explain better in this about this positive and negative sign. I told you the same method used for the whole chapter. Object is the one that gives out the incident ray, isn't it? Object is the one that emit the incident ray, and then it is the refracted ray that form the image. It is the refracted ray that form the image. That's why object distance we compare with incident ray, and then image distance compare with refracted ray. Only the object distance compare with incident ray. The rest like image distance and radius. Just now I talked about the radius, isn't it? Radius, all this radius also compare with refracted ray. Understand or not? Compare with refracted ray. Like this one, this radius, this radius and this radius, all compare with the refracted ray. Okay. If at the radius and the refracted ray same side, then it's positive. If the radius opposite is negative. See this one? This R1 is positive, this R2 is negative because opposite. That's how I determine. Okay, image distance and radius compared with refracted ray. If same side is positive, it's real image. If opposite side means it's a negative, value is negative, it's virtual image. Like you see this one. Now let's look carefully. Yeah. Now let's look carefully. First, I draw the incident ray. I draw the object. Yeah, object is over here. So incident ray come from here and refracted ray come from here. So like for this one, object is over here. So the incident ray is over here. Okay, and then I need to draw first. Yeah, this is the object over here, incident ray here, and the object is over here, incident ray is over here. You see that? And then the other side is the refracted ray. The other side is refracted ray. Like if object is at the right hand side, then the refracted ray is at the left hand side over here. Okay. This one refracted ray at here, this one refracted ray at here. Then about these two. Yeah. Now, maybe some of you may ask me, should I put the object at the left-hand side or should I put the object at the right-hand side? If I want to use the lens-maker equation, if I want to use this lens-maker equation to determine the focal length, lens-maker equation, if I want to use this lens-maker equation, should I put the object at the left-hand side or right-hand side? Both can accept, both accepted. I want to use the lens-maker equation 1 over f equal to n2 over n1 minus 1 over r1 minus 1 over r2. Both can be accepted. You understand or not? If you want to put the object at the left-hand side, then this is the first surface, and the left-hand side will be the first surface, the right-hand side will be the second surface. If you put the object at the right-hand side, the right-hand side is the first surface, the left-hand side become the second surface. Let's say both is the same lens, you surely get the same. Same answer. You get the same focal length for both. If you don't believe me, you can use both methods to calculate the focal length. You surely get the same focal length for both lens. It's just the R1 and R2, they switch together. They switch, and then the sign also they switch. You see that? R1 and R2, the sign they switch, and they just switch. They just switch places. You surely still get the same focal length. So you want to put the object at the left hand side, or you want to put the object at the right hand side, both can be accepted. But we just be consistent lah. Yeah, be consistent. If you always put at the left hand side, just put at the left hand side. If you put at the right hand side, just put at the right hand side. Be consistent. Actually, both will arrive with the same focal length, same answer. Don't worry. Now, about this. Okay. Now I want you to look about this positive and negative sign. Okay. I want to explain one last time. Okay, how to determine image positive and radius positive? Look carefully, yeah? Very simple. Just look carefully. Yeah. Second, yeah, because it's processing. Yeah, you see that? Yeah, it's processing. Okay, hold on a second. Now look carefully. You see this object. Yeah, I remember object. Okay. Okay, we adjust it so that it's clearer. Object compare with incident ray. Understand or not? So this object same side with incident ray, isn't it? So the object distance is positive. Now, let's say the image is formed at this side. Let's say the image is formed at this side. So the image distance is same side as the refracted ray. I told you the image compared with refracted ray. So the image same side as the refracted ray. So the image distance is positive. V is positive. Do you see that? V is positive. Okay, image is positive. if the image is formed over here, opposite to the refracted ray, that means it is formed, the light already go to the other side. Here has no light. What I can say, here has no light. Here just now got light. Got light. So this one is called the real image. But this one is called the virtual. This one is called the virtual image. Virtual image, because no light. So this one place got light with the refracted ray same side is the real image, so it is V positive. This one, this image is opposite to the refracted ray. It formed at the place with no light, so this is called the virtual image. Yeah. So this V is negative, this V is positive. Now how about the radius for the lens maker equation? For the lens maker equation, radius R1 and R2, which one is R1? This one is the surface with the incident ray is the first surface. Okay, so the radius of it, I should draw it here. You see, this is the radius. You see that? So so this R1, so R1, this is R1, same side as the refracted ray. This is R1. Okay, this is R1. This R1, isn't it? R1 is same side as the refracted ray, so it's R positive. So, but for the second surface, it is the radius is over this side. You see that this radius is over at the left hand side, opposite to the refracted ray. So this R2 is negative. This R2 is negative. Okay, because opposite. That's how we determine the positive and negative. Let's look at this concave lens. Concave lens. So now this object is positive because same side as incident ray. This image is formed over here. Anyway, concave means concave lens only form one type of image, which is virtual image. Okay, this image is formed opposite to the refracted ray. Do you see that? Opposite to the refracted ray. So this is V negative because no light. The light already go the other side. So here is no light. So this is just a virtual image. So that's why it's V negative. Because opposite to the refracted ray. Now how about the radius? The radius, this one is the first surface. This one is the first surface. This one is the first surface. Because with the incident ray, and then radius one is over here. You see that? Opposite to the refracted ray. So it's negative. This R is negative. And then for the second surface, this is the second surface. Because got the refracted ray come out. Okay. So this radius, look at the shape. The sphere is at this side. This is R2. R2 is over here, same side as the refracted ray. So is positive. R2 is positive. Very easy. How about this one? Okay. Now if this one, okay, can see now. This is the object, incident ray here, so same side as the object, so this object is positive, real object. And then if image is formed at over here, this image forms same side as the refracted ray, so this is a real image. So this V is positive. But for this one, if the image is formed over here, opposite to the refracted ray, then this is the virtual image. This is the virtual image. The V is negative because no light. And then this R, okay, both are positive because same side as the refracted ray. Which one is R1? This surface, where it received the incident ray, this one is R1. Okay, this is R1. So the R1 is over here also, R1. So R1 also same side as the refracted ray, same side as the refracted ray. So this R1 is positive. And then for the second surface is over here. This is the second surface. You see that? The second surface, this is the second surface. And then R2 is over here also, R2. R2. So it is also same side as the refracted ray. So this R2 also positive. Understand? And then for the last one, if the object is over here, incident ray comes, refracted ray comes or goes out here. So the image is formed opposite the refracted ray. So this is the virtual image. This is the virtual image. Okay, V is negative. V is negative. Now, if the and then look at which one is the first surface. First surface is the one received the incident ray. This is the first surface. Okay, where's the radius? Radius is over here. This is R1. You see that? So this R1 is opposite to refracted ray. Opposite, so it's negative. And then how about the second surface? Second surface is over here. This is the second surface. Second surface is this one. So the radius is over here. Radius is over here. So R2. This R2 is positive or negative? Opposite to refracted ray. Opposite. So this R2 is negative. That's how it is. Yeah. This both R is negative because opposite to refracted ray. This both R is positive because same side with refracted ray. Okay. So first drawing the incident ray and refracted ray is very important. And to draw the incident ray and refracted ray need to depend on where is the object. Yeah. Object is at the left hand side. Incident ray must come from the left hand side. And then the refracted ray at the other side. If the object at the right hand side, incident ray come from the right hand side, and then refracted ray at the other side. Okay. So that is the light can pass through. Okay. So one more thing. I think I have explained everything about sign convention. Later on I need to explain about the ray diagram. And then about the characteristics of the image. I haven't talked about the characteristic of the image form. That's the following videos. Yeah. So I've say everything here. What I can say is the difference between mirror and the lens. Mirror is reflection. Incident ray and reflected ray at the same side. The light cannot pass through. But for the refraction at spherical surface and the thin lens, the light can pass through. Incident ray at one side, refracted ray at the other side. That's what makes them become opposite. Because of this reflection and refraction, one light cannot pass through, one light can pass through. That makes the characteristic of image for this mirror and lens become opposite. Concave mirror become convex lens. Concave mirror become like convex lens. And then convex mirror become like concave lens. That's what I can say. We will learn more about this later on. All right, and thank you for your time watching these lengthy videos, because it's full of concepts. Yeah, thank you for your time again, and see you in the next video.